Adding and subtracting fractions with unlike denominators. You're probably familiar with 1/4 plus 2/4. 1/4 plus 2/4 is, denominator is the same, so we can keep that denominator the same, and 1 plus 2 is 3. So that 1/4 plus 2/4 is equal to 3/4. Now, if we're given denominators that are not the same, I think that you would agree with me that 1/4 plus 1/2 also equals 3/4. And the way to look at this is that 2/4 is equivalent to 1/2. And we have that 1/4, the other addend, which is the same. So when we have fractions with unlike denominators, what we do is we make them into fractions with like denominators by writing an equivalent fraction. So an equivalent fraction for 1/2 is 2/4. So that 1/4 plus 2/4 does equal 3/4, where I showed my work for why 1/4 plus 1/2 equals 3/4. 3/4 is in simplest form, so I am done with my addition work. Here I have 7/10 minus 2/5. And what I want to do is I want to find the common denominator, that greatest common denominator. And so the greatest common denominator is 10. So since 7/10 already has a denominator of 10, I can just write 7/10. And what I want to do is I want to go ahead and write an equivalent fraction for 2/5. I want to write 2/5 in tenths. 2/5 is equal to 4/10. At that point, my denominators are like and the same, so I can go ahead and do that work there. 7 minus 4 is 3. I asked myself, is 3/10 in simplest form? The answer to that is yes, and then so this here is my answer for 7/10 minus 2/5. Here I have 7/10 minus 5/15, and to find that common denominator, I could list out the multiples of 10, and I could list out my multiples of 15, and then I would see, 30 is a common multiple. And in that case, if I use 30 as that common multiple, how would I get to 30 from tenths? I multiply by 3. So I do that in the numerator to get 21/30ths. How would I get to 30? Multiply by 2 to get 30ths here, and multiply by 2 here to get 10/30ths. So 21/30ths minus 10/30ths is equal to 11/30ths. And since 11 is prime, and 30 is not divisible by 11, this here is in simplest form. Here's a problem for you to try. 12/20ths minus 1/5. Go ahead and make 1/5 into 20ths. And subtract. Hit pause. I asked you to make 1/5 into 20ths, and the way that we do that is multiply by 4 in the numerator and denominator. So we would have 12/20ths minus 4/20ths, equaling 8/20ths. Did you remember to simplify? Hope so. Let's divide by 4 in the numerator and denominator. 8 divided by 4 is 2. 20 divided by 4 is 5. And 2/5 is in simplest form. Give yourself a pat on the back if you got that correct. If not, learn from your mistake. Look where it is that you went wrong. We have 2/3 minus 1/5. This is another problem for you. I suggest a common denominator of 15. Go ahead and hit pause. Here's your solution. Times 5 times 5. 10/15. 2/3 does equal 10/15. 1/5 equals 3/15. And if I subtract them, 10 minus 3 is 7. 7 what? 7/15. And 7/15 is in simplest form. This does work much the same way for mixed numbers. What we do with mixed numbers is we still look for the common denominator. In this case, we would have a common denominator of what? Easiest one to choose is eighths. I'll show you that if you accidentally chose a different denominator, that you would still end up with the same answer. You're just going to have to take more steps. And then so what we'll do is we'll show you sixteenths. To get to sixteenths for this mixed number, we multiply the numerator and denominator of the fractional part of that mixed number by 2. And then so 3 times 2 is 6, and 8 times 2 is 16. And then we go ahead and write the whole portion of the other mixed number of 1. And again, we do the same strategy and same approach, where we're going to go ahead and make that into sixteenths. So 1 1/4 equals 1 4/16. At that point, since we have like denominators with these mixed numbers, we can go ahead and do our subtraction work. 6/16 minus 4/16 is 2/16. And then with our whole numbers, 3 minus 1 is 2. So we have 2 2/16, which we can go ahead and simplify by dividing the numerator and denominator by 2, and remember to write out that whole number, so it's 2 1/8. Problem would have been much easier, our previous problem, if we had just chosen to change 1 1/4 into 1 2/8. And at that point, we could have gone 3/8 minus 2/8 is 1/8, and 3 wholes minus 1 whole is 2 1/8. We would not have had to simplify and do that one last step. Let's go ahead and review. We have 2/7 plus 1/8. And the way that we can solve this problem is we need to find that common denominator, or that common multiple, of 7 and 8. Of course, we could just keep on listing them out, 14, 21, until we got all the way up to 56. And I'd have to write 8, 16, 24, until we got all the way up to 56. An easier way, an easier approach, might be just to take that other denominator. And then what I mean by that is we multiply by the other denominator. And then so the other denominator, if I'm looking at the 7, is the 8. So we multiply by 8 there. The other denominator, if I was talking about 8, is that we would multiply by 7. And remember, what we're doing here is that we are reviewing how to make a common denominator. We need that common denominator so that we can go ahead and add these fractions together. So now that I know that the common denominator is going to be 56, that's why I went 7 times 8 here and 8 times 7 here. At that point, if I do one thing in the numerator, I better do that same thing in the denominator and vice versa. And because I multiplied in the denominator by 7 there, I have to multiply in the numerator by 7. Our equivalent fraction then for 2/7 is what? Think. Right, 16/56. What's our equivalent fraction for 1/8? Hope you said 7/56. And if you add those carefully together, what do you get? 23/56. Since 56 is not divisible by 23, because 23 is a prime number, then we know that 23/56 is in simplest form. If this answer was not in simplest form, you would have to simplify it.